Good morning, folks. Hopefully everyone can hear me okay. My name is Will Hatler. I'm field scientist for the Western Pasture and Land Management business for Corteva, located in the Western U.S., just outside of Boise. And today I'm going to co-present with my coworker Jerome Otto, who's a market development specialist located in Scotts Bluff, Nebraska. And the topic is why herbicides sometimes fail. And so I'll have the first half of the presentation and I'll hand off to Jerome here in a bit. See if we can advance here. Okay, so, herbicide applications are somewhat complex. There's a lot that goes into it. Success is not automatic. We don't just load up the sprayer and go out and spray and automatically have success. There's a lot that goes into it from a technical standpoint, a lot of things that we think through before making an application. And quite frankly, it's easier to have an application fail than it is to have a successful one. So what we're going to try to do here today is point out some of the things that could possibly lead to poor results in the field and ways to alleviate that and give you the things that you think about before making an application and all the checklist type items. So I think the repercussions from a poor herbicide performance are pretty obvious for those of you that make applications and do this for a living. First and foremost, if you have a failed application, you haven't controlled the weeds that you're looking to control. And so that's the objective at the end of the day is success in your objective. And so then you've got to go back and retreat at times, which takes both time and money. So there's a cost effectiveness issue. There could be some reputational damage, to your technical expertise or your operation. And so, preparing before and making sure you've got all the things in place for a successful operation are key to your business. And then on the flip side of that, obviously, if you have a successful operation, successful application, you've got, you eliminate your non-performance issues, you eliminate having to return to the site and potentially treat again, and then maintain your reputation, reduce your costs, and then customer satisfaction at the end of the day is what we're after. So the first potential pitfall that we're going to talk about when it comes to successful applications is plant condition. So one of the things that can lead to poor plant condition is drought. And what that does is quite a few things to your plant condition. First of all, it can shut off the plant processes. So what plants will do when they're under water stress is close the leaf stomata, which helps them preserve moisture inside the plant. And so if those stomata are closed, that's the entryway for the herbicide to go into the plant. So if you close that off, you're going to have less penetration into the plant with the herbicide. Your leaf condition can be damaged as well, which prevents herbicide uptake. Another reaction that plants will have when they're under drought stress, and especially brush species, is they'll develop a waxy cuticle on the leaf, which again prevents herbicide uptake. And then leaf senescence begins to occur, so they start to brown out. And at that point, the processes that lead to herbicide uptake have stopped in the plant as well. And so it's a little bit counterintuitive at times. You may think, if a plant is not healthy, it's on the way out, then I'm going to deliver the fatal blow with a herbicide application at that point. But really, what we want is a healthy growing plant that's going through all of the functions that it requires to take in that herbicide and move it down to the root system. And so an unhealthy plant does not do that. Another thing that we look for is insect damage. So if your plant foliage is damaged by insects, that plant is probably under stress, and you may have a reduced control or reduced herbicide uptake. And so plant conditions very important. On the other side of things, can it be too wet? Absolutely. I think one thing folks don't think about is dew. So having heavy dew in the morning, just for instance, I do research trials with all of our herbicides, and one of the things that we don't do is spray wet plants. So if there's a heavy dew cover on plants, it's generally better to wait until that burns off some. Um, and then obviously, if you're going to spray a foliar herbicide, that herbicide has to have an opportunity to enter through the leaf. And if you get a rainfall immediately after or during an application, it's gonna wash that herbicide off the leaf and reduce your efficacy. If you're applying a soil active herbicide and are relying on pre-emergent control or longer lasting soil residual control, a big rain event after application may wash that product off site or cause it to leach in the soil below the root zone that you want it to be active in. So for soil active herbicides, that usually we require some rainfall to activate those, but you can have too much rainfall. And so it's a balance. You don't want it to be too dry or too wet. You want the optimum conditions to guarantee the best activity. When we start to think about making an application, preparing in all the ways that we can, collecting all the documents available to us that give us the information about products. Site evaluation is absolutely mandatory. We have to know what are the species that we're going after, what's present on the site to know what products to use and what timing to use and all of the things that we think about from an application standpoint. Are there plants there that we want to preserve and not control? That's a key piece as well. Do we want a herbicide that is selective, as in only controls broadleaf weeds, for example, or brush? What are the physical requirements of the job? How many acres? How many personnel do we need? How long is it going to take? Are the products that we need for the job going to require an applicator license? So many of the herbicides out there, you have to have an applicator license to purchase and use. And so you need to know if those products that are needed require a license. All right. So species identification is absolutely critical. We develop these herbicides through a lot of research, and it is species specific. And so that comes down to the herbicide selection, the rate, the timing, everything involved is based on an individual species. So case in point here, this is absinthe wormwood, a common non-native species in the Midwest, upper Midwest. And it's targeted quite a bit in pastures and non-crop for control. Well, it sort of resembles some sagebrush. It has a sage look to it. It smells like sage. And so for that particular plant, we have very specific recommendations and control methods. We've got them listed out here, some of the things that we recommend, and it's based on research. And so if you misidentify that plant and think it's a sage, or you think or you look at a sagebrush and think, oh, that's absinthe wormwood, it's a totally different recommendation. And your control is probably gonna fail because you've misidentified the plant. So just comparing the wormwood to some sage species, the friend sage there, and then the other one shown, there's some similarities, and it could be easy to misidentify that particular plant. And if you zoom in a bit and look at the leaf structure and the appearance, the color, and all that, very similar. So it's really easy to misidentify plants. Not everybody is a plant ID expert, and there are tools available out there that you can utilize to help you out in the field, identify the plant, and then have the proper treatment prescription. So just a few things here. There's a ton of things online, apps, all of these things that you can get these days. We have some weed and brush ID guides that are available to you for free if you scan that QR code. It's a very good resource, and they do include treatment prescriptions for the species in there as well. So I'll leave that up for a second for you to scan that QR code if you'd like. Picture this as an app that a lot of folks use in the field. You take a picture of the plant and it helps you identify it. There's other apps, you can use Google Photos to identify plants, even your iPhone Photos app. These days, I think you can identify plants through that as well. But just making sure that you go through the effort to identify the plant to have the right control method. That's critical. Okay, so plant characteristics, plant growth stage. Once you've identified the plant, you then get into the details of, okay, when do I target that particular plant? So identify if it's an annual or a biennial or perennial. There's different ways we treat those things. Growth stages. Um, it may be after emergence or it breaks dormancy. If there's been a mechanical treatment on the site, there are things that we need to do there as well. So if you think about say a woody plant that's been cut down above ground that was a mature plant, well, it has a massive root system. So you have to allow enough regrowth to occur that you have a proper root to shoot ratio that allows you to get enough herbicide on that product to affect that root system. And generally for annual weeds, we're going to spray those when they're younger and actively growing. Biennials, uh, the rosette stage is a great time to target those, and then up through bolting. For the most part, when we get to flowering or putting on seed for biennials, you may be not necessarily too late for any control at all, but your control is going to be reduced, and you're going to have generally poor results there. Perennials, as opposed to annuals, you're going to wait until they're at the bud or blooming stage, or in the fall at rosette, because generally in the fall, perennials are putting down carbohydrates to the roots. And so, we're speaking in generalities here, and it's really based on the individual species. Again, it gets back to identifying the species and then digging into the recommendations for those individual species. So once you've identified your species, then you've got to select the herbicide. And there is no one size fits all product out there that does everything. There are some very broad spectrum products that work on a lot of different broadleaf weeds and woody species. High noon is one of those. But you really want to look into what's the active that's going to achieve the objective. Again, there's no one size fits all. And then the use site. The use site has to be listed on the label. Um, I've gotten the question quite a bit. Does the species have to be on the label for you to use it? Uh, well, yes and no. So, yes, in the fact that the research goes into adding species to the label. And so, if it's on the label, we know that it controls it. What dictates what you can legally do on a site is the use site. So, if the product is labeled for rangeland, you can use it on that site, and then roadsides, etc. All the use sites listed allow you to legally use that product on that site. Um, and then beyond that, you want to make sure that the species is on the label to ensure that you're going to control it. So again, is the target weed listed on the label? Put a lot of work into researching species, writing labels. Um, if the species is not on there, you need to talk to your territory manager. There could be a tank mix that we can recommend that's going to help you as well, if the species is not on there. Is the growth stage listed on the label? What are the parameters that are suggested for spraying that individual plant? We talked about growth stage. Uh, dig into that and find what the best time of year is, what times of year to avoid, and then if a tank mix is potentially needed, that may or may not be listed on the label, and it may require you to talk to a territory manager or someone with that information. We'll get into the modes of action here in a bit and why we want to utilize different modes of action, sites of action at different times. So your timing is very species dependent and it's critical. So looking at the picture here, this particular plant is going into senescence. You can see the foliage starting to turn there, and that would not be a time we would treat that plant. It would most likely not transport the herbicide down into the root system where we want it to be. Okay, another thing that can lead to some poor performance is if we don't use the right adjuvant, or if we use no adjuvant. Most of the time, herbicides are going to require an adjuvant to achieve optimal performance. So an adjuvant is anything that's put in the tank with a pesticide that increases the biological activity, and it will modify the physical properties of that spray solution and do some specific things out there in the field uh, to help you achieve that pesticide efficacy. And there is no one size fits all adjuvant, just as in a herbicide, no one size fits all. It's a very specific recommendation usually. So why put one in the tank? To reduce the surface tension on the actual leaf surface. It helps that herbicide solution or the spray solution spread on the leaf, get better penetration. Also helps with evaporation, absorption, things like that, and can improve rain fastness. So it just overall helps the activity and the effectiveness of the herbicide application. Your label is generally going to tell you what type of surfactant or adjuvant to use. For instance, here it spells out methylated seed oil with a rate, 1% volume per volume, or a non-ionic surfactant. Those are probably the most common in our world in range and pasture and VM would be MSOs or NISs. And usually the rate is given in a percent volume per volume, which is a percent of your overall spray solution. So for instance, 1/4% NIS would be 1 quart in 100 gallons. Okay, let's spend a minute here talking about herbicide resistance, and that can absolutely lead to reduced efficacy, failed herbicide application. Um, Herbicide plant resistance is increasing. So this chart here, you can see the timeline there, and it's maybe a little bit dated, but when you get it to about 1990, you can see that line graph shoot skyward. Um, there's some things that are related to that, but this is just to show you that the number of weeds that are resistant to herbicides continues to increase to this day. What causes resistance? Well, in any natural weed population, there are going to be some individuals in a population that are naturally resistant. So if you look at the picture on the upper left, that represents, a weed population out in the field. So that one green plant there could be naturally resistant. And if you spray the herbicide, that one plant is going to survive and then put on seed, reproduce clones of itself, and then you're going to have more resistant plants. And if you continue to use that same active ingredient on that field, eventually you're going to have a more majority resistant population in that field. Why is this continuing to increase? Well, in some crops fields, predominantly it's in crops. Over the years, we've used multiple applications of the same product in one season, and then using the same active ingredient over and over for consecutive growing seasons and using no other control options leads to a resistant population that can then spread to other fields. And it's an issue, especially with some particular species and active ingredients. There are weeds out there that are highly susceptible to resistance, and part of it is being prolific seed producers. Some of the major offenders we know of, obviously kochia, Palmer amaranth, or pigweed. And that picture on the right shows where one resistant kochia plant took off and rolled through a field and dropped seed all the way across the field, and you can see what it left behind there. So your weed seed dispersal mechanisms play into it, and they're how prolific they are as a seeder. So what herbicide factors increase selection intensity? Herbicides that act on a single site of action or a single mode of action, and then again, the ones that are widely used across multiple markets, whether that be right away, non-crop, in-crop cereals, soy, and soybeans and corn, obviously are large acre crops that we see a lot of resistance in, and cereals is a really big one. So here are some of the modes of action that we see a lot of resistance out there in the field with. Number one would be the ALS inhibitors, and that would include sulfonylureas like methylsulfuron methyl and things like that. The PS2 inhibitors, atrazine would be a big one there. The ACC ACE, that's the FOPs and DIMs, so like clethodim and some of those grass control herbicides that are used in crops a lot. And then when you get down further there's less resistance to glyphosate, but it's absolutely out there. And then your synthetic auxins, there are some resistant weeds as well. Weeds that are resistant to multiple modes of action is rarer, but there are some out there that are resistant to 2 or more modes of action. So how do we fight it? I think we've gotten a lot better around talking about these issues and resistance and developing strategies. Number one would be using multiple modes of action, whether that's in a product that has multiple modes of action or tank mix. That would be number one. And then rotating chemistries in different applications. So more of a program approach where we switch products between applications, not use the same one over and over. Those are the ways that we keep these chemistries working longer and keep them in the toolbox that and preserve these tools for the future. Okay, I'm going to turn it over to Jerome here.
Very good. Thank you, Will. And welcome, everyone. Great to be here. Want to remind everyone as we go through this, if you have questions, please feel free to put them in the Q&A. And when Will and I are done here, we will go ahead and answer those questions. So, water quality. One of the things that can and does impact performance of herbicides is water quality. That includes things such as water turbidity, fancy way of saying, what if you have suspended solids in your spray solution because of where you're getting your water from? Clay, silt. Certain herbicides will bind to that. And since they're binding to it, they're not as available to control the weeds. Same thing with water hardness. So, described as dissolved minerals such as calcium, magnesium, iron. Again, different herbicides will have different susceptibilities to this type of a thing. And then finally, water pH. We have ingredient or active ingredients that we work with, which really are impacted by pH, and it can determine the longevity or the soil half-life in it. So these are things to keep in mind. And keep in mind, even within the same county, you can have very wide variances in this. So it's good to be aware of where you're getting your water from and how that may impact these qualities of the water. Another thing that can really impact it is if you have formulation problems, especially when we are tank mixing. If we were all in person and I asked for a show of hands, how many of you have faced this type of a situation that you see in the photo? I bet most of your hands would go up. There's two problems that result from this. One, think of the time and the effort that is going to go into cleaning out a spray solution when you have a mess like this. More importantly, though, if you are having this type of a coagulant, that herbicide is not going to be available to control weeds. So let's make sure that when we're tank mixing more than one herbicide, that we're following the proper tank mix order. And again, just to go back to the point that Will made earlier about resistant weeds, the more we are dealing with resistant weeds, whether we're talking about a range and pasture or a land management site like roadside or utilities, we're going to be wanting to go with more than one herbicide in the tank. So how do we know if we have multiple herbicides, what order we put them in? Well, there is an acronym that I like to use called WAILS: wettables, agitate, liquids, emulsifiables, and surfactants. And I'll start by saying, as you're dealing with herbicides, you really need to know the formulation of the herbicide you are dealing with, because that formulation will give you the information as to what order to put them in. So, for example, we always want to begin with our spray tank with about 2/3 water filled in it. I tell the story that early in my career, I was helping someone spray. It was 5 o'clock in the morning, and we were doing a combination of 2,4-D and glyphosate. And since it was 5 o'clock in the morning, I knew better, but I put the glyphosate and the 2,4-D directly into the tank with no water. I spent the next 2.5 hours digging cottage cheese out of that spray tank. So always start off with your tank 2/3 full, and then make sure you have constant agitation. Then you're going to go with any wettables or any dry material, and you're going to add them in slowly, and you're going to make sure they're in complete solution before you go to the next state. And again, number 3, agitate. You're going to keep that agitation going. Then add your liquids with constant agitation. then emulsifiables, and then finally any surfactants. Will did a great job talking about their surfactants. Those always go in last. So let's use an example. Let's say that you're doing some bare ground work and you've determined that you want to tank mix 3 different herbicide and an adjuvant. You're going to be adding glyphosate, high noon herbicide, spike ADDF, and then a non-ionic surfactant. So as we've talked about, the order in which you add those is critically important. Let's go through a real life example of what you'd want to do. So again, we're going to start off putting 2/3 of your spray tank with water first. That gives enough water to be able to get things into solution. And we're going to start the agitation in that tank and we're going to keep it going throughout this entire process. So water first, then wettables, in this case, spike ADDF, which is a dry flowable. So we're going to add that to the tank with the agitation, and we're going to be patiently waiting to make sure that that spike goes fully into solution. Once that has occurred, then we're going to add our liquids, in this case, high noon herbicide. We're going to add that in slowly, letting it, again, with constant agitation, letting it completely go into solution. And then finally, our non-ionic surfactant. So that, and by the way, NIS is the acronym that we'll often use. So with that agitation, once that's all done, then we'll fill that tank up full with water, and now we are ready to go. Out of all the complaints I've been on in the past 40 years, the number one reason for non-performance is a poor job of sprayer calibration. This is going to have a huge impact on our herbicide performance. And for those of you that do commercial applications, I'm not so concerned about this because this is something you're already doing. I'm more concerned for those of you who maybe sell herbicides over the counter. I always encourage people to make sure that we are doing a good job of calibration. And I'm not going to make this into a calibration clinic, but let me just run through some numbers that I tell people: either commit these to memories or print it off on a cheat sheet and keep it with you. So 1 acre, 43,560 square feet. 1 mile is 5,280 feet long. If you're calculating area, that's done by multiplying the length times the width. So for example, let's say that you're going to be spraying an area 500 feet long by 800 feet wide. That's 400,000 square feet. You take that, divide it by the 43,560 square feet per acre, you know that you are spraying 9.2 acres. If you know the rate per acre, you can do the math. You know how much to add to your spray tank. Speaking of doing the math, 1 gallon is 128 ounces. A quart is 32 ounces. A pint is 16. So 1 gallon equals 4 quarts or 8 pints. And if you're doing small amounts, for example, with Milestone herbicide, 1 ounce equals 29.5 cc's. This second to the last one is one that I've really found critically important as I'm doing calculations. So when you're traveling at 1 mile per hour, you will travel 88 feet per minute. And the last one, it takes 10 times longer. It takes 10 times longer to walk a complaint than it does to calibrate. I'll admit, I kind of made that one up, but truly, folks, this is one that I have found to be true over the course of my career. And this is true. So I have this with a photo of cattle, this, all of which is true if you're doing range and pasture or if you're doing roadside or utility. This is the number one thing I really stress to people is the importance of sprayer calibration. It has a gigantic impact on your herbicide performance. So at the start of the year, I always encourage people to do it throughout the year or intermittently, and especially if you are changing any parts to that sprayer, take the time to do it. You'll be glad that you did. Let's talk about sprayer maintenance. So I grew up on a farm in Minnesota. One thing I know from experience is that all equipment, regardless of what it is, all equipment can and will break down. So maintaining that equipment is really important. Any total herbicide program has to begin with a well-functioning and well-maintained sprayer. So if you look at things like streaks or over application, under application, all of those can be a result of poor maintenance. So let's talk about some of the things that we need to do with your sprayer at the end of the season and why it's important. And what are some of the costs of failing to do it? So some of the things to keep in mind when you're looking at this. If you have your sprayer, if you take good care of it, not only is it going to last longer, which will save you money, but if you do a good job in the fall, next spring, when you begin your application season, it'll take you less time and money to start up. Oftentimes, again, having grown up on farm in Minnesota, in the winter time, we had time to work on the equipment. So the spray equipment itself continues to escalate in cost. I realized almost everyone on the call today is not a row crop sprayer, but a brand new John Deere Rogator sprayer can run over $800,000. And that's just emblematic of how those costs have increased. Your spray season, even if it's beginning to get cold and the days are beginning to get short, your spray season isn't truly over until you've adequately inspected, repaired, and winterized your sprayer. So we all tend to have more time in the winter. Next spring, when the phone's ringing off the hook, I want to make sure that all of you are ready to hit the road and you don't have to do maintenance that could have been done over the previous months. So, one of the things that tends to happen is herbicide residues tend to build up throughout the season. And I use the analogy, let's say that you do dishes immediately after dinner, or let's compare and contrast that to putting them in the sink, letting them dry and harden for 2 days. It's easier and quicker to do dishes right away. The same thing is true with the sprayer maintenance. This is a photo that a customer of mine sent to me showing the residue that had built up in the filters in their sprayer. So in this case, those that residue was still relatively soft and was fairly easy to clean up. Had that person let it sit all winter long, I about guarantee they would have been completely replacing those filters. By the way, just an aside, if we were in person and I were asking all of you, is there anything wrong with this photo? I'm glad that the customer sent me the photo, but I did kind of chuckle to myself because all of the herbicides that Corteva sell recommend and require the PPE, the personal protective equipment of long sleeve shirt. So I'm glad the person's wearing gloves, but they probably ought to be wearing a long sleeve shirt as well. Just an aside there as we're talking about a complete approach to our spraying. So let's talk about fall sprayer maintenance. Here we are in November. Depending upon where you're at, you may still be spraying or you may have come to the end of it. But at any case, whenever the end of your spraying season is, as we talked about, it's always easier to remove pesticide residue from tanks, hoses, and screens before they harden and dry. We want to make sure that the water is removed from your sprayer before freezing can damage. And that damage can be to pumps or pipes or fittings or flow meters. And that can really be expensive, as I have found out personally. In addition to the spray equipment, your sprayer itself, whether that's a truck or a four-wheeler or a side-by-side, changing the filters and fluids of that sprayer at the manufacturer's interval really will help you make that equipment last longer. Any properly maintained equipment is going to have less downtime during the busy season, and it's going to be safer to operate. Again, all of us, our spray season tends to be short. We want to make sure we're maximizing our effectiveness and not having unnecessary downtime because we didn't maintain the sprayer. So functioning spray equipment, it's going to make you more efficient and more effective. You'll get more acres or more miles sprayed. Obviously, that's going to generate more revenue for you. When you purchase a sprayer, I always encourage people take the time to read the owner's manual for whatever their recommended schedule of maintenance is. Again, not just for the spray equipment, but for the machine itself. Keep a maintenance log, whether that's on paper or electronic. That'll help you organize and maintain your scheduled maintenance items, making sure that you're meeting those needs and making sure that it is going to be well maintained. Fall is a great time of the year to prepare your equipment for that next spray season. So, some of the things to keep in mind: changing the fluids, like we've talked about, maybe changing oil, replacing any broken parts. What about adding antifreeze? Again, we want to make sure that, for example, I'm in Western Nebraska. It was 22 degrees last night. So, if I would have had a sprayer which had water in the pumps and the lines, and I would have left that out overnight, I would now be spending money replacing that. So add antifreeze where you need to and thoroughly inspect that entire spray rig. So making sure your lights and your flashers work, changing fluids, grease fittings, make sure that you're filling the fuel and hydraulic oil tanks. Take a look at your engine belts, the hoses. Are you seeing any visible signs of wear? Same thing for visible signs of wear on the hose clamps or straps or bolts. Take a look at your tank. Are you seeing on your spray tank itself, are there any signs of wear or degradation? What about your battery? This is something that, again, having grown up in Minnesota where it would routinely get well below zero in the wintertime, that temperature can really impact your batteries. So your batteries are important, obviously expensive. Modern sprayers have so many modern electronics on them that we need to have uh, the batteries. Those electronics, those computers, they can drain a battery over winter, even while the sprayer is in storage. So you may consider removing the battery over the winter from your sprayer and storing it in a heated location. How about your battery? Let's talk about your battery cables, making sure that the connectors and the posts are clean and that if there's corrosion that's building up, get that cleaned up so that next spring you're ready to go. If you're not going to remove the battery, maybe consider putting a trickle charger on your battery over the winter time to make sure that that is maintaining its charge. Other things to inspect at the end of the season: take a critical eye to your hose clamps. Are they rusted or corroded? Maybe it's time to replace those. Keep in mind, the wider a clamp, the more contact with the hose and the stronger the hold. So this is really important if you have narrow clamps that can eat into or begin to dig into your hoses. Keep in mind, if that clamp fails, the hose does as also. So if the clamps are doubled, then offset by 180 degrees. Making sure your tank is secure. I know a custom applicator who found this out the hard way going down Interstate 25 in Wyoming at 75 miles an hour. Fortunately for him, the tank didn't have anything in it, but it did not survive that. So make sure tighten the straps, the hoops, and the bolts on your tanks and inspect them to ensure there's no visible wear signs. And it's common for the straps and the bolts that hold the tank to become loosened due to vibrations. So if you're going to test them, the best time is when the tank is full so that you're making sure those clamps are functioning well properly when the tank is at its most vulnerable stage. Special consideration to any poly tanks you have. I know there's a lot of poly tanks out there. Sunlight, the number one nemesis of your poly tanks. That UV radiation degrades the tank, and sometimes that can be very difficult to see. It's not always easy. So the use of a water soluble pen that can help you take a water soluble pen, apply it to like a 6 inch by 6 inch square area and wipe it off. Any remaining ink in a crack, like a spider web, those are signs that you should be aware of that you're probably beginning to suffer from some loss of elasticity, and that can lead to failure. If you have a brittle poly tank and something happens to strike that, you can have a catastrophic loss, and we have seen that before. Other thoughts: power wash dirt and grease off the outside. If you're putting this into a shed, consider rodent traps. Unfortunately, rodents love to chew on wires, and that can be costly. Examine your hitchers, tires, receivers. Again, remove all the water. We don't want to have freezing. That causes the water to expand, and that can cause damage. A lot of customers I know consider putting antifreeze solution in, and they flush that through the system. And so beware of the type of antifreeze. So Some of it can be dangerous to pets and wildlife. Always check the owner's manual for recommendations on what type to use. We talk about cleaning, triple rinsing out your application equipment at the end of the season. Again, we talked about we want to do this right away. If you allow that to sit over a period of time, pesticides tend to settle to the bottom of a spray tank, and as they harden and dry, it's more difficult to remove them. So don't forget to check those filters. Physically look on the inside of your spray tank and make sure that we're not seeing any residue in there. And then run the pump until all the water is out. Flush and drain all the hosiers, strainers, valves, pumps. And I always tell folks that make sure that residue, make sure that you, if it is labeled for pastures, when you collect that residue, dispose of it in an approved use site. So I've mentioned several times, don't leave water in a spray tank over the winter time. This is a mistake that I made 2 years ago, me, the guy who gives classes on what not to do. So I got out to the field about an hour away from my shop. And if you look closely on the right-hand side, well, if I zoom in right before that nozzle, what happened? I left water in that spray wand. It expanded and it burst. So when I wanted to start spraying, it instead just made a cloud. It cost me $175 to repair the equipment, but more costly than that, it took me 4 hours. By the time I drove back to town, got the parts I needed, drove back out, repaired it. The point being, I could have spent 5 minutes in putting a antifreeze in there. It would have saved me a lot of money. So this is a real life example. I learned the hard way. Take care of your equipment at the end of your spray season. So let me touch on some other reasons why you may not be getting the performance you want. If you end up not getting your herbicide to the where you intended to spray, you won't get as good a control. In addition, you may get off-site, off-target damage. So there's a couple of ways that can happen. Spray drift. This is where when you're spraying, before it ever hits the ground, wind causes that to move off-site. And so we have to be physically very, very careful when we're spraying to make sure we don't have spray drift. So some things to keep in mind. Don't create a fine mist. Avoid creating droplets smaller than 100 microns. You don't want a mist out there because the smaller the droplet is, the farther it'll travel in a given wind speed. If you're doing individual plant treatments, be aware that if you're slashing that spray wand, that also can create a mist. So keep your movements slow and smooth, and keep your nozzle as close to the ground as you can while still getting good coverage. So some key variables: droplet size, spray height, proximity, how close are you to a sensitive site, and then wind speed. So going in further, this is a great visualization of the droplet size. If we keep the wind speed steady at 3 miles an hour and the height steady at 10 feet, look what a difference it makes as we go from a large droplet size that only goes 8 feet to the smallest droplet size that can travel over 1,000 feet. This is why it's critically important you're not creating a fine mist in the field. Also, if we keep the wind speed steady at 6 miles an hour, look what happens as we raise the nozzle. So we're going to keep the droplet size steady at 300 micron. We're going to keep the wind speed steady at 6 miles an hour. When we raise that nozzle from 1.5 feet off the ground up to 3 feet, look what happens. We go from 0.15 feet in how far it goes to 1.17. So over 10x increase in distance by raising that nozzle. Again, you want the nozzle high enough to get coverage, but no higher than that. How close are you to sensitive areas? I've often told folks the worst tongue lashings I've received in my career have not been we didn't control weeds. It's been when an applicator has damaged someone's garden or desired rose bushes. For those of you that have been on those calls, those are emotional. We want to avoid them. So how close are we to susceptible trees or crops, gardens? What about areas like schools or bus stops or playgrounds? We absolutely don't want to be contaminating those areas. And then water bodies. If we're not using products that are labeled for aquatics, we need to be aware how close are those water bodies. Talk about wind speed. So we need to monitor wind not only at the beginning, but throughout our spray application. So you can do that with handheld devices. You can do it with your phone. And there are label guidelines on all the herbicide labels. For example, if you look at the high noon herbicide on page 5, it says, quote, do not apply when wind speeds exceed 10 miles per hour. So we want to make sure we're not doing that. Again, I carry one of these handheld wind monitors in my truck at all times, and I really encourage you to do the same. Keep in mind that wind currents can drastically affect, and those wind currents can be affected by things like wind breaks or tree lines or houses or hills or valleys. So we need to have a 360-degree awareness when we're out there spraying. And keep in mind, wind speed, the drift potential can actually be really high when there's no wind. And that's because calm and low wind conditions may indicate the presence of a temperature inversion. I'm sure most of you know, but that inversion is where a layer of warmer air is above a layer of cooler air, and that traps that area. And so you can get products that move a long ways. Drift potential is actually lowest between 3 and 10 mile per hour. What about drift potential? Though, like drift retardants, is it possible to use too much? It is. This was sent out by a coworker of mine in Kansas. They used so much drift retardant that they ended up getting very poor coverage on the leaf. So you can see where they didn't get good coverage and they burned holes, but they didn't control those weeds. Quickly moving on to volatility, that's where you get it down where you want it to go, but then it moves from a liquid to a gas and it moves off. How do we reduce that? Well, let's make sure that the formulation we are using is going to be the most conducive to have low volatility. Finally, one of the things that can really impact the performance is making sure our water volume is the same. And there's no right water volume. Many of you in range and pasture can go out at 10 gallon per acre of water. Others who are doing TVC or bare ground work are going to be wanting to go out at 50, 75, or even 100 gallon. So let's make sure that we are adjusting to the conditions and using the correct volume of water. A drought can impact that. And then finally, keep in mind that if we are, depending upon the species we're going after, we may want to set expectations. It's not a 1 year application. It's going to be a case where we have to monitor and we have to retreat as necessary. So, in summary, if you look at all the things that Will and I talked about, you want to identify what species you want. Based on that, select a correct herbicide or more likely herbicides tank mix you're going to use. Read those product labels, make sure you have the correct right, the correct timing, and then keep in mind all the things that we talked about between the environmental factors, agronomic factors, the weed stage, the product, and the application factors. So with that, Will and I are going to open it up to Q&A. And Will, this first one, I'm going to toss to you. You talked about the difference. You talked about mode of action of herbicides, and then you talked about site of action. Can you detail the difference between the mode of action as well as the site of action? What's the difference and what does that mean?
Yeah, I mean, so you'll get people that use the terms interchangeably. There is some technical difference. Mode of action generally is the overall. Um, so, for instance, an auxin inhibitor or synthetic auxin, that would be the mode of action. Site of action would be the specific part of the plant that mode of action is active on. That is, it's hard to describe, and it's confusing at times because they get used interchangeably. But there are some differences. Site of action is the very specific enzyme or whatever it may be within the plant that is targeted, and then the mode of action is the function or the plant function that's targeted.
Thank you. And from a commercial standpoint, I would add uh, the difference in a practical sense often is which product or products you want to be tank mixing together. So, for example, with high noon herbicide, we have two active ingredients, aminopyrrolid and rinskor. They're both auxin, they're both growth regulate herbicide, but they have different site of action. So, in a practical standpoint, if two herbicides have a different site of action, what it means to you, the applicator, is that it means that they may control different weeds. So, Will, is that a fair summary?
Yep.
So, second question here, and Will, I'll start and then ask you to come in and give a technical perspective. The question is, how soon after an application should I expect mortality of a weed or a brush? And you're going to hate the answer. It depends. And what I mean by that is oftentimes you may begin with an annual broadleaf weed. You may begin to see symptoms within 3 or 4 days, but you may not see complete mortality, the complete death of that in, for example, 30 days. If we're talking about brush control, tree or brush control, if you're speaking to a field scientist like Will, they oftentimes won't make a determination of efficacy until 1 year after. So it's going to depend upon whether it's an annual, biannual, or a perennial. The longer the life cycle of the species, the longer you're normally going to have to wait to see mortality. It also depends upon, as Will mentioned, how actively are those weeds or brush growing. The more perfect the growing condition, the quicker you'll begin to see symptomology. Will, any comments you want to add to that?
Nope. I think you covered it perfectly.
Very good. Well, those are the questions that we have. We're going to end by saying if you have questions, we certainly encourage you to reach out to your Corteva land management and range and pasture specialists. I want to bring your attention down to the lower section there, vegetationmgmt.com or rangeandpasture.com are two excellent websites that will bring you to information on not only our products, but how you would find who your local territory manager is. We would welcome you to reach out to us and to have us help you design a program which will help you meet all of your needs. And so, with that, we really thank you for joining and we appreciate your business. Hope you have a good rest of your day.
Good morning, folks. Hopefully everyone can hear me okay. My name is Will Hatler. I'm field scientist for the Western Pasture and Land Management business for Corteva, located in the Western U.S., just outside of Boise. And today I'm going to co-present with my coworker Jerome Otto, who's a market development specialist located in Scotts Bluff, Nebraska. And the topic is why herbicides sometimes fail. And so I'll have the first half of the presentation and I'll hand off to Jerome here in a bit. See if we can advance here. Okay, so, herbicide applications are somewhat complex. There's a lot that goes into it. Success is not automatic. We don't just load up the sprayer and go out and spray and automatically have success. There's a lot that goes into it from a technical standpoint, a lot of things that we think through before making an application. And quite frankly, it's easier to have an application fail than it is to have a successful one. So what we're going to try to do here today is point out some of the things that could possibly lead to poor results in the field and ways to alleviate that and give you the things that you think about before making an application and all the checklist type items. So I think the repercussions from a poor herbicide performance are pretty obvious for those of you that make applications and do this for a living. First and foremost, if you have a failed application, you haven't controlled the weeds that you're looking to control. And so that's the objective at the end of the day is success in your objective. And so then you've got to go back and retreat at times, which takes both time and money. So there's a cost effectiveness issue. There could be some reputational damage, to your technical expertise or your operation. And so, preparing before and making sure you've got all the things in place for a successful operation are key to your business. And then on the flip side of that, obviously, if you have a successful operation, successful application, you've got, you eliminate your non-performance issues, you eliminate having to return to the site and potentially treat again, and then maintain your reputation, reduce your costs, and then customer satisfaction at the end of the day is what we're after. So the first potential pitfall that we're going to talk about when it comes to successful applications is plant condition. So one of the things that can lead to poor plant condition is drought. And what that does is quite a few things to your plant condition. First of all, it can shut off the plant processes. So what plants will do when they're under water stress is close the leaf stomata, which helps them preserve moisture inside the plant. And so if those stomata are closed, that's the entryway for the herbicide to go into the plant. So if you close that off, you're going to have less penetration into the plant,